If a numbers are in the sequence of geometric progression, the sum of the terms is given by a into 1 minus r power n divided by 1 minus r. If nothing is mentioned and the series is infinite here, so we can clearly use the formula s infinity is equal to a by 1 minus r. We'll get here r square in the form of minus 1. So therefore r square minus 1 is equal to 0. So that implies r is equal to plus r minus 1 as the solution. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. In this session, we'll study about the geometric progression. So last session, we have studied about the sequence and series of arithmetic progression. So here, geometric progression is a sequence in which the term and its preceding term is separated by the common ratio. So the common ratio here have taken an example of 2, 8, 32, 128. You can see here this is 2 4s are 8, 8 4s are 32, 32 4s are 128. So here the constant is nothing but the common ratio. So the ratio is given by the quotient form of T2 by T1. Suppose if you take 8 by 2 or 32 by 8. If you take any term by its preceding term, there will be a constant here. And here the constant is given by 4, which is called as the common ratio. And again here, the very first term is nothing but a in the geometric progression. Now the geometric progression, the nth term of a geometric progression is given in the form of Tn is equal to ar to the power n minus 1 here. So for instance, if a is the first term, then r may be fraction or may be greater than 1 also. It may be a number which is in terms of fraction or in terms of integers also. So ar square, etc. And hence the last number is given in the form of ar to the power n minus 1. Which means if you want to find out the fifth term, it is ar to the power 4. If you want to find out the 10th term, it is ar to the power 9. Next. Now the sum of n terms of a GP. That means if a numbers are in the sequence of geometric progression, the sum of the terms is given by a into 1 minus r power n divided by 1 minus r. Here r is less than 1. That means r may be any fraction. If suppose r is any integer which is greater than 1, then the formula is reversed here. It is r power n minus 1 divided by r minus 1. Now if this is the sum of n terms of a GP, then if we say n terms here, then it must be a finite set. If suppose there are infinite number of terms in a sequence of geometric progression, then the sum of infinite terms of a GP is represented by S infinity is equal to A divided by 1 minus R, where A is the first term and R is the common ratio. Find the sixth element of the GP 3, 6, 12. Now here we need to find out the sixth element of a GP. That means we need to find out T6. So to find out T6, then it is A R to the power 5. Now let's see what is A here. A is equal to 3. What is the common ratio? 6 by 3 or 12 by 6. So R is equal to 2 here. So now 3 into 2 to the power 5. So 3 into 32. So that is equal to 96. So the sixth term of the following GP is 96. Next. Find the sum of the GP root 3, 1 by root 3, etc. So here it's an infinite series. So let's find S infinity. Now here S infinity is equal to A divided by 1 minus R. So what is our A here? It is root 3. And 1 minus r is 1 minus 1 by root 3. So this becomes root 3 divided by root 3 minus 1 by root 3. So which can be written as 3 divided by root 3 minus 1. So this is the sum of infinity. Now suppose find the sum of the GP root 3, 1 by root 3 up to 7 terms. If they have given the same series up to 7 terms, then we need to find out S7, sum of first 7 terms of this progression. Now here, we know here the value of A is root 3 and the value of R is 1 by root 3. If you divide T2 by T1, then you will get 1 by root 3. So therefore the common ratio is in a fraction and it is less than 1. So we should use the formula a into 1 minus r power n divided by 1 minus r. Now since I said we need to find out the sum of 7 terms, so what happens here? So in the place of a we have root 3. Here it is 1 minus 1 by root 3 whole to the power 7 divided by 1 minus 1 by root 3. So what happens here? Again it is 1 minus 1 by root 3 form. We can shift to root 3 here. This becomes 3 divided by root 3 minus 1. And here we have 1. Now 1 to the power 7 is 1. Root 3 to the power 6 can be written as root 3 into root 3 into root 3 whole square 3 times. So 3 into 3 into 3, 27. So this becomes 27 root 3. So this will be the sum of first 7 terms. So there is a difference. If they ask you to find up to 7 terms, then you should use this formula. If nothing is mentioned and the series is infinite here, so we can clearly use the formula S infinity is equal to A by 1 minus R. Next, find the sum to infinity of the GP 1, 1 by 2, 1 by 4. Let's take the first term. A is equal to 1 and R is equal to here 1 by 2 by 1. So it is 1 by 2. We need to find out S infinity. So S infinity is equal to A divided by 1 minus R. So value of A is 1. R is 1 minus 1 by 2. So it is 1 over 1 by 2 which is equal to 2. Next question. How many terms of the GP 1, 3, 9 will amount to 364? So they have given the value of Sn, the sum they have given. So they have given Sn is equal to 364. Also they have given the series and the sequence here, where we can write the value of A and also R. So we can see here 3 by 1 is 3. So R is equal to 3. So now let's use the formula here. Since R is equal to 3, it is greater than 1. So here we can use the formula A into R power n minus 1 divided by R minus 1 is equal to 364. Now value of A is 1. R is 3 power n minus 1 divided by 3 minus 1 is equal to 364. So 3 minus 1 is 2. Let's multiply 2 here. Then here 3 minus 1 is equal to 728. 3 to the power n is equal to 729. Minus 1 when it goes there, we'll add 1 there. Now 729 can be written as 3 to the power 6. Now since base are equal here, the powers can be equated. So therefore, the value of n is 6. That means we need to add 6 terms in the GP where it will amount the sum 364. Next question. The sum of the first 8 elements of GP is 5 times the sum of the first 4 terms. Find the common ratio. We need to find out R here. So the given sum of first 8 element, which means S8 is equal to 5 times the sum of first 4 terms. That means S4. Now let us assume the common ratio is greater than 1. So for that purpose, I'll take here A in the form of R power 8 minus 1 divided by R minus 1. Since I don't know R here, neither I don't know A, I'll keep it same. I know only the value of n in each side. So here we have 5 into A into R power 4 minus 1 divided by R minus 1. We can cancel A on both sides, R minus 1 on both sides. R power 8 minus 1 can be written as R power 4 minus 1 into R power 4 plus 1. So using A square minus B square, which can be written in the form of A minus B, A plus B. So R power 8 can be written as R power 4 whole square and 1 in the form of 1 square. So I can write it like this. And here I'll shift this term to the left hand side. Then this is 5 into R power 4 minus 1 is equal to 0. Now we have a common term here, that is R power 4 minus 1. Then we will get R power 4 plus 1 minus 5 is equal to 0. Now let's take R power 4 minus 1 is equal to 0 and here it becomes R power 4 minus 4 is equal to 0. Now r power 4 minus 1 can be written as r square minus 1, r square plus 1 is equal to 0. Now I can equate r square minus 1 is equal to 0 because r square plus 1 is equal to 0 is not real. Because we'll get here r square in the form of minus 1. So therefore, r square minus 1 is equal to 0. So that implies r is equal to plus r minus 1 as the solution. Now if you consider this, r power 4 minus 4 is equal to 0. Again we can write this as r square minus 2 and r square plus 2 is equal to 0. So again r square plus 2 is not real. So we can equate only r square minus 2 is equal to 0. So r is equal to plus or minus root 2. So therefore the value of r is equal to plus or minus 1 or plus or minus root 2. Next question. Find the three numbers in GP whose sum is 39 and their product is 729. We know the numbers in GP always start in the form of A, AR square, etc. So let me take the preceding term by A, then it has to be in the form of A by R. So instead of taking these three as the first three number, I'll take A by R, A, AR as the first three terms. Now let us consider the sum is 39. So given A by R plus A plus AR is equal to 39. So next they have given their product is 729, which means A by R into A into AR is equal to 729. We can cancel R, so A cube and this can be written as 9 cube. So since the index are equal, we can equate the base. So therefore A is equal to 9 here. Now since A is equal to 9, let us substitute here. So here if you take A as a common factor, we will get A outside and we are left with 1 by R plus 1 plus R is equal to 39. So let me consider this as equation 1 and this as equation 2. Now put A is equal to 9 in equation 1, then it is 9. 1, let us solve this fraction, we will get 1 plus R square whole divided by R is equal to 39. Now let's multiply 9 here, then it becomes 9 plus 9R plus 9R square is equal to 39R. So if we write this in the form of a quadratic equation, minus 39 plus 9 becomes minus 30R plus 9 is equal to 0. 9 9s are 81 and if you have to take two numbers here, the product is 81 and the sum is minus 30. So I'll take 9 9s are 81 in the form of 27 3s are. Then I'll get 9R square minus 27R minus 3R plus 9 is equal to 0. So 9R if you take a common factor, then we'll get R minus 3 and here again minus 3 if you take R minus 3 is equal to 0. So we will get R minus 3 is equal to 0, 9R minus 3 is equal to 0. So R is equal to 3 or R is equal to 1 by 3. Now here if you take A is equal to 9 and R is equal to 3, the numbers are, so here we need to consider the number in the form of A by R, which means 9 by 3. So 9 by 3 means it is 3. Next it is A, so 9. Next it is AR, so it was 27. So the numbers are 3, 9 and 27. And suppose if you take A is equal to 9 and R is equal to 1 by 3, then the numbers are again A by R, which is 9 divided by 1 by 3, 27. And next it is A, that is 9. And next it is A into R, which is 3. So whatever the ratio you take, your numbers will be in the form of 3, 9, 27 or 27, 9, 3. Next question. Find the sum of n terms of the GP, 5 plus 55 plus 555 plus etc. So that means the series continues with the number of terms with 5. So now let Sn is equal to 5 plus 55 plus 555 plus etc. until n terms. So to solve this, we have a method which we'll do here now. So we'll take 5 as a common factor. Then we are left with 1, 11, 111 plus etc. until n terms. Now I will multiply 9 inside the bracket and I'll divide by 9. Then this will become 999, 999 plus etc. until n terms. Now we have 5 by 9 here. 9 can be written as 10 minus 1. 99 can be written as 100 minus 1, which can be written as 10 square minus 1. 999 can be written as 1000 minus 1, which can be written as 10 cube minus 1. And it goes on until n terms. Now here I'll do 5 by 9. I'll separate the tens and ones. So 10 plus 10 square plus 10 cube up to n terms. Then I have minus. So if you take minus outside, it is 1 plus 1 plus 1 up to n terms. So now you can see here 10, 10 square, 10 cube. There is a difference of 10, common ratio 10, which means this is in GP. So when we have GP up to n terms, and here clearly A is equal to 10 and R is equal to 10, which means R is greater than 1. So we can apply the formula of GP up to n terms here. Then this becomes A into R to the power n minus 1 divided by R minus 1. And here we have minus 1 plus 1 plus 1 n times is n. And outside we have 5 by 9. So therefore, this is equal to 5 by 9 into. So this can be written in the form of 10 by 9, 10 to the power n minus 1 minus n. So this is the sum of n terms of the given series. In the same way, we can just replace 5 with 333, 333. We can also use the decimal form like 0.6, 0.66, 0.666 also. So the procedure will be the same. In today's session, we have discussed the nth term of geometric progression and the sum of infinite terms as well as the n terms of GP. I'll meet you in the next session. Until then, keep watching, keep learning, keep exploring. Thank you.